Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about diagonal canonical form. This is state space analysis, control system subject. Lecture series on state space analysis and lecture number 26. So our new topics, diagonal canonical forms. So what is diagonal canonical form and why diagonal canonical forms and what is the target? By diagonal canonical form, we can convert transfer function to, we can change or convert transfer function to state equation, state diagram and signal flow graph and ultimate stability of the system. So this is our target. So diagonal canonical form. A system defined by its transfer function may be needed to convert to a state model from analysis point of view. A state model is very much suitable for computer applications. Thus, an exact analysis can be carried out using the state variable models. Consider the general transfer function is as. So this is our general transfer function. Ys by us equals to b0 s to the power m plus b1 s to the power m minus 1 plus b2 s to the power m minus 2 plus bm minus 2 s square plus bm minus 1 s to the power 1 plus bm divided by s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2 plus a n minus 2 s square plus a n minus 1 s to the power 1 plus s to the power 0 into a n. This is the general transfer function where m numerator powers and denominator powers is s, and always in general case m less than or equals to n. So generally m less than equals to n. When m equals to n, the transfer function is, this is the condition, when m equals to n, the transfer function, just put here m equals to n. In this position, just this is the m and put n. Just put m equals to n, m equals to n, m equals to n. So this is the transfer function for m equals to n condition. A linear time invariant system is described by transfer function of the form. This is the transfer function from ys by us already discussed. b0 s to the power n plus b1 s to the power n minus 1 plus b2 s to the power n minus 2 plus bn minus 1 s to the power 1 plus bn, and denominator s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2 plus an minus 1 s to the power 1 an. So this is the nth order differential equation or nth order system, and numerator polynomials contains n number roots or n number eigenvalues, because the power of s, this is the power of s, n number roots, n number roots. So let the above equation is written as, this is the another form, ys by u of s equals to b0 plus d1 by s plus lambda 1 plus d2 by s plus lambda 2 plus d3 by s plus lambda 3 plus d4 by s plus lambda 4 plus dn by s plus lambda n. In this case condition, lambda 1, lambda 2, lambda 3, lambda 4, lambda n are roots of the characteristics equation or eigenvalues of the characteristics equations. So this is the partial fraction form transfer function nth order polynomial system for nth order polynomial systems. For this equation, multiplying both sides by us, so left hand side, this is the cancel, and right hand side b0 into u of s, and d1 divided by s plus lambda 1 into u of s. Similarly, d2 by s plus lambda 2 whole into u of s, and dn by s plus lambda n whole into u of s. So multiplying both side u of s, and we get ys equals to, this is the transfer function. Then this is the output, mainly output, and ys by us transfer function, where ys equals to system output and us equals to system input. This is the reference input. This reference input may be step, ramp, parabolic, impulse, sinusoidal, any type of input you can apply in this position. Then y of s equals to what? Y of s equals to b0 into u of s. This is fixed, but d1 divided by s plus lambda 1 whole into u of s. d1 us by s plus lambda 1 equals to z1 s, and d2 divided by s plus lambda 2 into u of s equals to z2 s. Similarly, dn u of s divided by s plus lambda n equals to zns, z of ns. This is the form d1 divided by s plus lambda 1 whole into us divided equals to z1s. That means z1s equals to d1 into us by s plus lambda 1. Similarly, z2s equals to what? Z2s equals to d2 into us by s plus lambda 2, z3, z4, z5 ... zn minus 1 s equals to dn minus 1 by s plus lambda n minus 1 u of s, and zns equals to dn into us by s plus lambda n. So zs equals to z2s equals to zns equals to ... zn equals to this. Then case number 1, z1s equals to what? Z1s equals to d1 by s plus lambda 1 into u of s. Then cross multiply, just this into this, this into this, and z1s into s, plus lambda 1 into z1s. This is the cross multiplication form. S into z1s plus lambda 1 into z1s equals to right hand side d1 into u of s, d1 into u of s, d1 into u of s. This is the first order differential equation, because s into z1s, this is the Laplace transform. So taking inverse Laplace transform, then we get dz1t by dt plus lambda 1 z1t equals to d1 into ut. After inverse Laplace transform, this is the inverse Laplace transform for this term. This is the first order differentiation, dz1t by dt plus lambda 1 into z1t, and d1 constant, us equivalent to us. This is the first order differential equation, and in this equation us equals to reference input, but z1t equals to output, but this is the position of the output, because rate of change of position is called velocity. So this output changeable or variable, because this is the position but this is the velocity. And when dz1t by dt integrate, then we get z1t lambda z1t. So this is the state variable. So z1t equals to first state variable, selection of the state variable. z1t, put z1t equals to x1, put z1t equals to x1, taking Laplace, taking differentiation both sides, and we get z1t. Z1t equals to dz1t by dt equals to x1 dot, and again z1 dot t equals to what? Z1 dot t equals to d into z1t by dt. So this is the for dz1t by dt equivalent to x1 dot. So put here x1 dot plus, this is plus sign, this is the plus sign, so this is also plus, and then lambda 1, this is the lambda 1 term, so lambda 1, this is also lambda 1, and z1t equals to what? This z1t equals to x1, then right hand side d1 into u of t, d1 into u of t. So this is the state equation. X1 dot equals to lambda 1 minus lambda 1 x1 plus d1 into u of t. So x1 dot is called state equation because left hand side differentiation terms or derivative terms, free of differentiation terms, right hand side. This type of equation is called state equation. So x1 dot equals to minus lambda 1x plus d1 into u of t, and next terms z2s equals to d2 by s plus lambda 2 into u of s. Similarly, x2 dot equals to what? x2 dot equals to minus lambda 2x2 plus d2 into u2. Again, similarly, z3s equals to d3 into u of s by s plus lambda 3 equivalent to x3 dot. x3 dot equals to what? Just put here lambda 3 and put here x3 and put here d3. So minus lambda 3 x3 plus d3 or u of t dot calculate z3, z4, z5, z6 dot zn minus 1s and cross multiply and taking z transform and selection of state variable. After selection of state variable, we get xn minus 1 dot equals to minus lambda n minus 1 xn minus 1 equals to plus dn minus 1 u of t, d1 n minus 1 u of t. Similarly, zn s equals to dn us by s plus lambda n equivalent to xn dot. This is equivalent to xn dot equals to minus lambda n xn plus dn into u of t. So this is the nth order differential equation or nth order system. So n number eigenvalues or n number roots of the system. First root lambda 1 minus, second root minus lambda 2, third root minus lambda 3, minus lambda 4, minus lambda 5, minus lambda 7 dot minus lambda n minus 1 and minus lambda n. So these are all eigenvalues or roots of the characteristics equation, Note that lambda 1, lambda 2, lambda 3, lambda n, roots of the characteristics equation or eigenvalues of matrix A. This is or eigenvalues or of matrix A, capital A. Then what is the state equations? The state equations are x1 dot already proved, minus lambda 1 x1 plus d1 into u2. Similarly, x2 dot equals to minus lambda 2 into x2 plus d2 into ut. x3 dot x4 dot xn minus 1 dot equals to minus lambda n minus 1 xn minus 1 plus dn minus 1 u of t, and xn dot equals to minus lambda n xn plus dn into u of t. So x1 dot x2 dot xn minus 1 dot xn dot are state equations. Then the state matrix can be written as, this is the form, x1 dot x2 dot x3 dot x4 dot xn dot left hand side, this is the x1 dot x2 dot x3 dot x4 dot xn dot. This is the left hand side matrix. So, and first coefficient, this is the first coefficient, x1 coefficient, lambda minus lambda 1. So put here minus lambda 1, multiply minus lambda 1 into x1. And others term x2, x3, x4, x5 in this position 0, in this position 0. So coefficients are all zeros. That's why x1 dot equals to minus lambda 1 into x1 plus d1 into u of t. So first equation satisfied. Then second equation, x2 dot, this is the x2 dot, and x2 dot equals to what? Minus lambda 2 into x2, x1 coefficient 0, and x2 dot minus, so minus lambda 2 into x2 only, and d2 into u of t, d2 into u of t. Similarly, xn dot equals to minus lambda n into xn, minus lambda n into xn plus dn into u of t, dn into u of t. So from state equations, we can easily calculate the state matrix. The state matrix can be written as this form, where this is the similar of x dot, this is x dot, this is the x dot form, and this is the A matrix. This is the A matrix. X dot equals to AX, this is AX, and this is the B matrix. This is the B matrix, and this is the U matrix. So our general form, x dot equals to AX plus B of B into U, B into U. X dot equals to X plus BU, where A matrix equals to, this is the A matrix, and this is the only diagonal matrix. This is only diagonal matrix because only diagonally lambda 1 minus lambda 1 minus lambda 2 minus lambda 3 dot minus lambda n only, and others all the values are zeros. This type of matrix is called diagonal canonical matrix or diagonal form of the system. So this is the diagonal canonical form. This is the diagonal canonical form. Then what is the output? Output ys equals to, already discussed, already proved, b0 us plus z1s plus z2s plus z3s plus z4s dot zns. So ys equals to, this is the equation, b0 us plus z1s z2s z3s dot zns, and taking inverse Laplace transform, then we get u of y of s equals to y of t, b0 constant, u of s equals to u of t, z1s equals to z1t, z2s equals to z2t, and z3s equals to z3t, and dot zns equals to zns equals to znt. Then put x, z1t equals to what? Z1t equals to x1, z1t equals to x1, z2t equals to x2, and z3t equals to x3. Similarly, znt equals to xn. Just put here z1t, z2t, z3t, znt value, and we get output y of t equals to beta b0 ut plus x1 plus x2 plus x3 plus xn, x1 plus x2 plus x3 plus xn. Then we can easily, the output state matrix can be written as, what is the output state matrix? Y of t equals to x1 coefficient 1, x2 coefficient 1, x3 coefficient 1, and x dot xn coefficient 1. So 1, 1, 1, 1, 1, x1, x2, x3 dot xn, and b0, this is the b0 term, this is the ut. This is similar to yt equals to cx plus y of t equals to, output equation y of c equals to c of xt plus d into u of t, d into u of t, d into u of t, where y equals to this matrix, this is the yt, and this is the c matrix, this is the xt matrix, and this is the D equals to, that means D equals to B0, and this is multi-input, multi-output systems. This is multi-input, multi-output system. So Y equals to what? Y equals, so UT equals to UT and D equals to B0, D equals to B0. So X dot equals to AX plus BU. This is the general form. Y equals to CX plus DU. This is the state matrix for state matrix. X dot equals to X plus BU, and output matrix CX plus DU, and YT equals to this, and A equals to, this is the A matrix, special type of matrix, only diagonal element, and these diagonal elements roots of the characteristics equation or eigenvalues of the characteristics equation. And B equals to, this is the B matrix, this is the B matrix, and C matrix, all the coefficients are 1.11111. So this is observable and controllable. And D equals to B0, D equals to B0. And this is the block diagram or state diagram. This is a state diagram. First equation, what is the first equation? First equation, x1 dot equals to minus lambda 1 x1 plus d2 u of t. So input equals to u of t. This is the input u of t. So put first draw u of t. Then u of t multiply d1. So draw here d1 block, d1 constant gain block, and this is the comparator. This is the comparator or summing point, and at this position, this is the x1 dot. This is the x1 dot. If x1 dot integrate, this is the x1. This is the x1. So x1 dot equals to what? X1 dot equals to minus lambda 1 x1 minus lambda 1 x1 plus u of t into d1t plus d1 into d1t into d1c. So put here x1 dot, and x1 dot equals to what? X1 equals to minus lambda 1 x1. This is the x1 dot integrate x1. This is the path x1 lambda 1 minus. So this path minus lambda 1 x, and this is the u of t into d1. So x1 dot equals to minus lambda 1 into x1 plus d1 into u of t. Similarly, x2 dot equals to what? x2 dot equals to minus lambda 2 into x2. Similarly, this is the x2 position, x2 dot. This is the x2 position. So x2 dot equals to x2 dot integrate. This is the x2 value. So this path x2 into lambda 2 and minus. This is the x2 into lambda 2 minus. So this is complete, and this is the u of t into d2. U of t into d2. So x2 dot equals to minus lambda 2 into x2 plus d2 into u of t. Similarly, xn dot equals to this is the xn dot, this is the xn dot. Xn dot equals to what? This is xn. So xn into lambda n minus. This is the xn into lambda n minus, because this is the form xn dot. And then this path dn into u of t. This is the u of t into dn. So xn dot equals to minus lambda n into xn plus dn into u of t. dn into u of t. This is general block diagram for diagonal canonical form. Thank you.